think we're back. Let's see. Just want to make sure. Am I live or am I not? Tell me. Okay, there we go. uh, so I don't know how the other stream ended. That's messed up on my part, but I did not mean to do that. It wasn't clear. But something I guess my point was that I was trying to make while I was pulling up the source was that the h of the Gaussian surface is the same as the length of the 3D linear charge distribution. So you can end up saying that the height of which I just defined here, the height of really this is the length of the 3D charge distribution. We can say that's equal to the height of this Gaussian surface down here, and you end up being able to cancel them out, right? So that's that problem fixed. Now we just got to figure out here why this is supposed to be. We know that E is supposed to be proportional to 1 over r squared by Coulomb's law, right? So, but the problem is if you can pull down powers in logarithms, right? So you end up with plotting 2 ln r, which is for sure not what we did in my lab. I don't think it was. Yeah, this is just taking the natural. My data is just taking the natural log of that. So, I'm gonna make a copy of it. Actually, I'm gonna mess around with the numbers. Just copy the electric field lab, and if we just do 2 times that, no, just 2 times. I don't. Sometimes I love sheets, and sometimes I don't. We end up with half a slope, which is certainly not ideal. I swear to God. This is exactly what my TA told us to do. This, like, plotting E versus ln r, but hmm. Oh, sorry. I'm getting the sniffles. At least that means I'm probably on the back half of this sickness. I just got it yesterday, I swear. But feeling better, I think. Still ain't keep it. You know, I've been sitting inside all day, so. Ln E versus 2 ln r. Expect slope of -1. What if we just did E versus ln r squared, maybe? Does it tell us to do that? So plot. If you plot the natural log of the electric field as a function of the natural log of the distance from the monopole, what should the slope of this plot be? What if we just try? What if we just did ln squared, you know? Or like r squared, sorry. Just e versus ln r squared, because I feel like we have the wrong. Um, yeah, I mean, it's the same, yeah, because it's equate. Like the same thing. 2 ln r is equal to ln r squared. Um, hmm. What are the rules for logarithms? Like, am I doing that right? I think I'm doing it right. I think you can just pull them out like that, but yeah, yeah. Well, this is valid math right here. Am I crazy? Is E not KQ over R squared? Let's see. Pull up the old equation sheet on the Canvas page. It's to practice. Oh, okay. I'm looking at the thing now. I think I was going about it wrong. I mean, all right. So E is KQ over R squared, but the electric field of a line charge with linear density lambda is 2K lambda over R. Which 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 conforms to what we're. But I don't know how he gets that. The electric field of a line charge with linear density lambda. I might just put it in there to be honest. And just say this is the electric field of a line charge with linear density. Yeah. I don't know if there's like a better way to do it, but well, there definitely is a better way to do it. Um, where's my line here? Using the formula for electric field of a line charge with linear charge density lambda with linear charge density lambda. Supposed to be frac 2K lambda for R. Just copy and paste that into here. You'd think E will be KQ over R squared, right? I might just have to tank the points in that one because I don't know. How can be proportional to just the rate? I mean, I was doing it earlier, right? I was doing the line charge earlier, but what do you integrate from? R is just the distance from, we'll call R the distance from the line charge to I have it pulled up right here. We're trying to do it. Yeah, see, my model from earlier doesn't fit then because we're trying to find the electric field distance from. This is so whack. I don't know, man. For a, yeah, well, this section's lost cause. I don't know. I could, it's like a physics helper, and I could ask. We'll just say that. I don't know. That's what we were told to plot. So yeah, you can see that this is not right. These two lambdas don't agree. Is that right? Did I integrate this right? Yeah, I did. It's ln, yeah, r to the negative 1 plus 1, yeah. Ln r minus ln r, well, ln big R minus ln r. And then I have to explain this. Where, oh wait, yep. Okay. Pardon me. And then remember, I've literally a page and a half of this freaking prediction thing. I don't know why they have so much predicting so many different things in this lab. It's kind of annoying. But should be a period after it. Procedure. We still confirm that these are the relationships for lambda 2 pi epsilon naught. Yeah, meaning if we take the slope and multiply it by 2 pi epsilon naught, we should just get lambda, but I did that down here. And figure 4. No, it's this one. Is that right? 2 pi epsilon, yeah, we should be multiplying the slope by 2 pi epsilon naught, which I think we're doing down here. Yeah, 0.26. 2 pi epsilon naught. And we can see they're like orders of magnitude off, like an order of magnitude off, which is not indicative of good data or like correct math. Why are we multiplying by r here? Okay. This, I'll copy and paste down here. Let's enter a conclusion. The exercise was to determine the relationship between electric field and radius, as well compared to theoretical experimental values. I don't make a prediction here is the issue. And I can't because I don't know. Yeah, I'm just gonna have to, this lab report is not good. Where I don't know, this is really frustrating. I don't know what I'm supposed to be doing at all. I think it's probably time I take a break from that. And I have a programming project to work on. I could do. I don't know if I'm supposed to be able to stream that though. Because technically it's confidential or whatever. So I think I've had enough of this today. Thanks.